In this video, we are going to solve problems based on similar triangles. To solve these problems, you need to know basic proportionality theorem and converse of basic proportionality theorem. If you don't know either of these, then before understanding these problems, please do visit our website to learn the same. So now, before we go ahead and start solving the problems, let us first revise these two theorems. The first is the basic proportionality theorem. It states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Say for example in triangle PQR, if ST is parallel to QR, then PS upon SQ equals to PT upon TR. Now, the converse. It states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So, for example, in triangle PQR, if PS upon SQ equals to PT upon TR, then ST is parallel to QR. The first question says, in the given figure, ST is parallel to PR and QT upon TR equals to QR upon RX. Prove that SR is parallel to PX. Here, in this question, we are given two things. First, ST is parallel to PR, and second, QT upon TR equals to QR upon RX. And we've been asked to prove that SR is parallel to PX. In order to prove this, first, we'll consider triangle PQR, where, as given, ST is parallel to PR. Therefore, by applying basic proportionality theorem to this triangle, we get QT upon TR equals to QS upon SP. We'll consider this as equation 1. Now, it's also given to us that QT upon TR equals to QR upon RX. We'll consider this as equation 2. Now, when we compare equation 1 with equation 2, we get QS upon SP equals to QR upon RX. Thus, in triangle QPX, SR divides the sides QP and QX in the same ratio. And so, by converse of basic proportionality theorem, we can say that SR is parallel to PX. Now let us look at the second sum. In this sum, two triangles are joined to give the following figure. In the given figure, angle AEF equals to angle AFE and E is the midpoint of CA. Prove that BD upon CD equals to BF upon CE. So, as you can see, we have been given that angle AEF equals to angle AFE and E is the midpoint of CA, and we have been asked to prove that BD upon CD equals to BF upon CE. So, before starting to solve this problem, we first construct a line through point C parallel to DF and meeting side AB at point G. Therefore, CG is parallel to DF. Now, we'll consider triangle AEF. In this triangle, it's given to us that angle AEF equals to angle AFE. Since sides opposite to equal angles of a triangle are equal, we can say that AF equals to AE, which can also be written as AF upon AE equals to 1. We'll consider this as equation 1. Now next we'll consider triangle ACG. In this triangle, AF is parallel to CG because by construction DF is parallel to CG. So now by applying BPT to triangle ACG, we get AE upon CE equals to AF upon GF. On cross multiplying, we get GF upon CE equals to AF upon AE. But from equation 1, we know that AF upon AE equals to 1. Therefore, by substituting this in the above equation, we get GF upon CE equals to 1. Therefore, GF equals to CE. We'll consider this as equation 2. Similarly, in triangle BDF, by construction, CG is parallel to DF. And by applying basic proportionality theorem, that is BPT, we get BC upon CD equals to BG upon GF. By adding 1 on both sides and using componendo, we get BC upon CD plus 1 equals to BG upon GF plus 1, which gives us BC plus CD upon CD, which equals to BG plus GF upon GF. Now since BC plus CD is nothing but BD and BG plus GF is nothing but BF, we get BD upon CD equals to BF upon GF. But we have derived in equation 2 that GF equals to CE. Therefore, by substituting this in the above equation, we get BD upon CD equals to BF upon CE. Hence, proved.
So that's it for today. Hope you have liked the session. If you want more such sessions, then do subscribe to our channel. You can also now check out our courses available on our website www.letstute.com. Until next time, keep watching, keep learning.